Hey guys, Dave Mazzetti here to give you an introduction to txtai. We're going to review the Introducing txtai notebook that's available on GitHub. So if you've never heard of txtai executes machine learning workflows to transform data and build AI-powered semantic search applications. Traditional applications typically do keyword search, where you're going to match keywords to rows. txtai is looking more to do semantic or contextual matching. It's backed by transformer models, sentence transformers, Hugging Face transformers, to be able to convert text into vectors and try to do similarity vector matching. So we'll hop in and take a look through this notebook to give you an idea what that means. First off, you'll see install in txtai from pip. You can also install through Docker, or those are the two main methods. Once you have it all installed, you'll see here you can create an embeddings instance. The embeddings instance is the framework for building vector search. The first thing you need to do when you create an embeddings is to set the path to a transformer model. In this case, it's using sentence transformers based on NLI and MPNet. That will then give you the ability to convert text into vectors. As we see here, you'll see that there's a couple sample sentences that have been picked. If you've seen a txtai demo before, these are the standard sentences that we like to show just to give you an idea of how txtai works. Next, you'll see a couple query samples and the results. And the important thing to see here is, let's look at the first one, feel good story, and main man wins $1 million from a $25 lottery ticket. You'll notice the difference between the query and the passage, that there's no real keyword matching happening within the query. There's no keywords within the results. Same for pretty much all of these examples below. So it has an understanding of language. It knows that good and winning a lottery are related. It knows that climate change and icebergs melting and collapsing are related, and so on. So this example so far is just using the transformer model to do the similarity matching. But next we'll see we can actually build an index so that if you have a lot of data, it can move a lot faster. So the exact same sample, we are then going through and building an index off the text and then looking through a series of queries and getting the same results. This way that if, say, you had 1 million records, you wouldn't want to have to vectorize all 1 million documents every time you run a query. That can be pre-computed and stored into an index. And those could be saved to disk and reloaded. That could be local disk. txtai also supports cloud storage like S3 and other cloud storage services on Azure and GCP. Next, an important thing, a lot of vector indexes, the conception is that you can only run it once and build it. txtai does support updates and deletes through an upsert operation. You can see here, it's going through and modifying one of the existing records and setting it to a new segment of text, and then running a search to see the new feel-good story. You see the initial one, and then after we update it, it's now saying that a baby panda born is a feel-good story, and then we can go back and also delete to show it goes back to the original text. That's important because if you go and you build 1 million vectors, you don't want to have to rebuild the whole index just to update one value. Up until txtai 4.0, there was really only support for storing vectors, and as you see out in this example, you would only store the vectors and the text is expected to be somewhere different. But with 4.0, you can store content within the database. That's an important change that just opens up a lot of different options. As you can see here, the embeddings index is rebuilt with content set to true and object set to true, which I'll cover in a minute, and then reindexed in another search run. Note that the text is actually pulled right from the index versus just being in an array as it was previously. And we can also add metadata to be able to search for other things. In this case, we'll just keep it simple and add the length of the text and run some queries, which you'll notice are in SQL. I'll cover that in a second. But yeah, just get an idea of, you can search where the length is greater than 40, or you can select some attributes about the length through SQL. That was another, cover in SQL, that was another 4.0 change where you can run SQL statements, as you see here, select columns from the txtai index where similar, that's a similar clause, which is, running a similarity query, but you also could have standard comparators, like just looking for the score or looking for the length, as in this case, or if you're looking for an actual direct match, if say you did want a keyword match, you wanted to match an exact word, you could do that, say where text contains or where text equals. All those are supported. Under the covers right now, it's using a SQLite database to do this, but there's other options for being able to store content, which will be coming in future releases. Object storage is another one. You could see here, it's going and getting an image and loading that into the index and storing a binary image and being able to select that. And you see here, it looked for a text row was similar to machine learning. It's going to pull back that text that we set previously, and then it's going to take the object image there and show it. So that's another important thing, that if you wanted to have metadata about images and you wanted to store, say, metadata text about it, be able to make that searchable and then pull the actual image when you show results, that's possible through txtai as well. So those are all just a real high level summary of what txai can do. There's a ton of examples on GitHub and dev.to. There's examples on Medium, plenty of articles out there. There's about 20 plus examples on GitHub that give you a start on all the different things that txai can do. This is just scratching the surface. I hope you've enjoyed it. Thank you for listening. Bye.